It was the boost clock of times, it was the base clock of times. It was the age of wisdom, it was the age of incredulity. Yeah, I don't know, I got nothing. I'm hoping that you're here to learn everything there is to know about the Strix Z270G gaming. We don't have enough time for that, sadly. But hopefully I can at least condense everything that you should know about this motherboard, micro ATX, into a short, easy to digest video. This is, of course, the Z270 chipset designed for Intel 7000 series desktop CPUs like 7700, 7700K, 7600, those kinds of things. It is backward compatible with Skylake, like the i7 6700, i5 6600, and so on and so forth. The ASUS Strix Z270G Gaming. Let's take a look. Micro ATX. I think micro ATX is kind of coming in vogue. You know, honestly, micro ATX is probably the perfect form factor for socket 1151 because you really can't run a lot of PCI Express peripheral I/O with socket 1151 because, you know, it's only got 16 PCI Express lanes plus the, you know, the 4 extra lanes that's to the DMI interface. Now, the Z270 chipset is an upgrade over the Z170 chipset, but it's an incremental upgrade. It's not really that much of an upgrade. And, you know, the Kaby Lake CPUs, the 7000 series, are also kind of an incremental upgrade over Skylake. But this really isn't the first time Intel's done this. You know, way back, you know, with Haswell, you know, we had the 4000 series CPUs in a similar socket configuration. 16 PCI Express lanes, DMI 2.0. Well, they did a Devil's Canyon refresh, which was aimed at enthusiasts and that kind of thing. And so that's kind of how I'm thinking of Kaby Lake. Kaby Lake is a desktop refresh to get you higher clocks, a little bit better performance. It's really not radically different from Skylake. In fact, the CPU core itself is virtually unchanged. The instructions per clock is virtually unchanged. There are improvements to the iGPU. The improvements around peripheral I/O and the chipset. The Z270 chipset now natively supports USB 3.1, although the implementation on different motherboards is a little bit of a mixed bag. So, micro ATX, well, you've got 2x1 PCI Express expansion slots. You've got 2 PCI Express by 16 expansion slots. The 2x16 expansion slots are available in a configuration of by 8x8 if you're going to run 2 devices, 1 in each slot, or by 16 nothing if you're just going to run 1 graphics card. But, you know, SLI graphics cards, I mean, some people do that. You can do that in micro ATX, but in this configuration, you could run a by 16 graphics card at by 8 with a high-speed peripheral in the other slot, and then you've got the by 1 slots. It also has 2 M.2 slots, one in the front, one in the back. So in terms of like peripheral I/O and connectivity, motherboard's pretty solid. No SATA Express, although it does have 6 SATA 6 gigabit per second ports, which is pretty good. One of the M.2 also supports SATA connectivity, but the other does not. Both of them are designed for PCI Express connectivity, however. Now, in terms of overclocking, power delivery, things like that, the power delivery circuit on this is ASUS Special Sauce. I asked for details on exactly what the implementation was and how it was laid out. I can't really tell you anything other than it's solid core construction. I'm probably going to take off, after we complete benchmarks and stuff like that, because I don't know if I can do this non-destructively, I'm going to take off the heatsink and try to find out more information about it. But the reason I'm not super curious about the VRM this time around with the Z270 is power delivery and good clean power delivery to the CPU is really not the limiting factor. Unless you've just got a really understandard power delivery system for the CPU, the problem is not going to be power delivery to the CPU. In terms of overclocking and in terms of the type of clocks that you can expect. There's a general intro video on Kaby Lake and the kind of overclocking you can expect and general strategy that's linked to in the description. This is part of a series. If you're thinking about buying this motherboard, there's actually a whole bunch of videos that I've done with the launch of the Z270 chipset when these first came available, so that you can look at it and say, oh yeah, there's all kinds of motherboards. So if you're window shopping or looking at different features and things like that, be sure to watch all the videos so that you can compare features and look for different stuff and watch the Kaby Lake overview so you know what kind of general features the chipset has and the CPU has. Hopefully it's not too repetitive. But this is a micro ATX motherboard, and I think micro ATX is the right form factor for socket 1151. If you need more PCI Express peripherals, you really would have to move up to a beefier chipset like X99, which is a different CPU and it's a lot more expensive. Or perhaps even the AMD platform once it's out. It's not out at the time of this video. Ryzen is on the horizon. So yeah, I'm hoping that Ryzen will bring down the prices for people that need more PCI Express connectivity. But in terms of sheer speed, 5 gigahertz on Kaby Lake, it's not that unusual. This motherboard can deliver 5 gigahertz on Kaby Lake. DDR4 4000, also not a problem, although I only tested up to DDR4 3200 with my Trident Z G-Skill memory. Worked perfect. It is 4-channel. Some micro ATX motherboards only give you 2 DDR4 DIMM slots. This gives you 4. Nice. It also has built-in Wi-Fi Go, built-in wireless. It's a 2-antenna solution, but it does have an external antenna. What else is in the box? Well, you get the manual, you got the stickers, you got a 20% off coupon for cable mod if you're gonna do like sleeved cables and that sort of thing. You've got cable labels, colorized cable labels, the driver CD, 2 M.2 mounting kits, an ROG coaster, Republic of Gamers coaster. You got 4 SATA 6 cables. You got the Wi-Fi antenna, the external Wi-Fi antenna that I mentioned before. It's not the rubber duck kind, it's the kind that goes on top of your computer, and it is magnetic, which is a nice touch. You got your flat black I/O shield. It's not reflective, it's just a flat matte black, which is nice. You got your high-speed bridge in case you are gonna run NVIDIA SLI. It does support Crossfire, of course. Then you've got a CPU insertion helper, insertion adapter. It's a little plastic thing that you can use to snap the CPU in and then snap that into the socket, which maybe makes the CPU installation a little easier. And then you've got a screw mount for 3D printing accessories. So one thing ASUS has done is provided 3D models available for different accessories that you can 3D print for the motherboard. Now, it's almost entirely aesthetic things that you can 3D print. So you could customize and 3D print an ROG label. You could customize and 3D print, you know, things to go in the M.2 slot that you can see through the side window of your case, that sort of thing. And it includes specific mounts on the motherboard so that you could screw, you know, a 3D print into the motherboard. I'm hoping to do some demos of that and have some fun with that, but it wasn't quite ready in time for the launch of Kaby Lake, so what are you gonna do? Let's take a look at the peripheral I/O on the back. On the back of the motherboard, you've got your 2 Wi-Fi Go ports. You've got 2 USB 3.1 ports. Now this is provided by an AS Media controller, one Type A, one Type C. Then we've got DisplayPort and HDMI. Then we've got 2 USB 2.0 ports, a PS2 mouse and keyboard combo port, and that's for people like me that are still running a Model M. Then we've got 4 USB 3.0 ports, Intel Ethernet, that's an i219V. Then we've got the Supreme FX 8-channel audio and optical SPDI FOut. Now the Supreme audio codec is implemented in the far corner of the motherboard. It is as far away from everything as possible to minimize EMI interference. It is on a separate part of the PCB, which is a nice touch. And the audio front panel connector is on that same part of the isolated printed circuit board. So what are we working with in terms of connectors on the board? Along the bottom edge of the board, you've got the audio front panel that I mentioned before, TPM, and then you've got an RGB header. Now, included in the box is an RGB header extension cable. Then you've got 2 USB 2.0 header ports for internal peripherals that you might run, a standard USB 3.0 style front panel header. Then you've got your clear RTC jumper, and then you've got an external temperature sensor. So if you have one of the ASUS external temperature sensors, temperature thermistors, you can plug that in and then run that wherever and be good to go. Then you've got a 4-pin hybrid PWM and DC fan header, and then you've got your front panel headers. Now in total, this motherboard has 5 fan headers, one of which is designed for a water pump, which means high current, you know, dedicated control, that kind of thing. And the fan speeds and profiles are fully customizable from within the Uefi, but we're gonna do a full tour of the Uefi in just a minute. On the front edge of the motherboard, you've got your 6 SATA connections that I was mentioning before, and look at this, it's a new connector. This is for USB 3.1 front panel connectors. Now, strictly speaking, you should be able to run USB 3.1 through the existing legacy connector. But what ASUS found in compatibility testing, what they told me was that a lot of cases, the USB 3.0 front panel is a little bit sketchy. And so while it might work at 5 gigabit, it's not going to work at 10 gigabit. So ASUS has partnered with Lee & Lee and some other case manufacturers to come up with a new front panel connector that will give you guaranteed USB 3.1, no problems, adequate voltage delivery connections at the front of the case. That was the other thing with USB 3.1 is that you've got a little bit more voltage delivery and you can't necessarily deliver that kind of electrical current through the legacy USB 3.0 connector. And this connector, I think, is designed to address some of those issues, but time will tell. Also along the front, we've got another fan connector, and at the very top edge of the board is another RGB connector. So this is a second RGB LED strip zone. So you can run 2 RGB LED strips off of this motherboard with 2 different zones for software control, which is really a nice touch if you're into RGBing out your case, I guess. I'm really genuinely surprised at how many people actually put a lot of work into really blinging out their case. I mean, it's cool. I've seen, there's a lot of really cool builds on our own forums, actually. So if that's your thing, I mean, that's cool. Then we've got our VRM assembly. Now, one thing I noticed about this VRM assembly is that there's no heat pipe between the two heat sinks. That's a really common thing that I've seen this generation, is heat pipes connecting the two VRM assemblies. But it seems like ASUS has got the efficiency down to where the VRM really doesn't generate a lot of heat. Even when I had this thing overclocked to 5 gigahertz, not with the stock cooler, obviously, more on that in a minute. But when I had this thing overclocked to 5 gigahertz, I was like, that's weird. The heat sinks for the VRM are basically cold. So I wasn't running the benchmark all that long, maybe like an hour. So, you know, I mean, cold, slightly warm, might be exaggerating just a little bit, but I was surprised that the VRM really was not hot at all, which perhaps bodes well for the longevity of that 5 gigahertz overclock. Now, so like I was saying before, incremental improvement over Z170. This is not, you know, if you've got Skylake, you're not going to run out and replace your system. At least I hope you wouldn't. If you got something older, you know, even something really old, like 3-4 generations back, you know, your instructions per clock is not really a lot different. But you do get insanely way better connectivity for all of your peripherals. Things like M.2, things like USB 3.1, things like really high speed, you know, Ethernet adapters if you're going to add in a 10 gigabit Ethernet adapter, or multiple PCI Express peripherals on this relatively inexpensive platform. Or if you know, don't already have a chip that's going 3.8 to 4.2 gigahertz, you can get 4.5 to 5 gigahertz on the Kaby Lake platform if you go for the top end i7. About 75-80% of CPUs will be able to hit 5 gigahertz on Kaby Lake, which I think is Intel's secret weapon. If you want to know more about that, just the general discussion of Kaby Lake, you're gonna have to watch the Kaby Lake intro video, which is also linked in the description. So if we've got incremental improvements to the hardware, what about everything else? Well, one place that I think ASUS has improved quite a bit is in their software, not just the Uefi, but also the software bundle that comes with the machine. Now, the software bundle is all Windows applications, so if you're going to run Linux with this board, we did do some Linux testing to confirm that all the peripherals work. It pretty much should, because Z270 is just an incremental improvement over Z170. Should work, should be fine, but we tested in Linux anyway, just to make sure that the audio works and that the Ethernet adapters work and that sort of thing. The improvements are in the AI suite and DIP5. Basically, you know, some motherboard manufacturers have gone with having a preset table of known good values, and so it's like, oh, we know that Kaby Lake will overclock with this based on our sampling of 1,000 processors or 5,000 processors or whatever. ASUS has done similar, but they use that as a starting point. So what their software does is once you install it in Windows and you want it to, you know, do the intelligent overclocking, you basically just hit a button and it'll do a bunch of stress testing, and you can configure how long the stress testing runs. And it'll reboot the machine a bunch of times and check stability and really dial in the settings. And what that means is that while it starts from a stable preset, it'll back off on the voltage and it'll push the clock speed. Well, I think it pushes the clock speed first and then backs off on the voltage, depending on how much of an overclock you want. And also, it takes into account your thermal solution. So it's like, all right, let's see if you could deal with a worst case scenario. No, in fact, it cannot, which is fine. I mean, that makes perfect sense. This is an Intel stock cooler. You should never, ever use an Intel stock cooler with either Skylake or Kaby Lake. I'm going to strongly recommend for pretty much all Kaby Lake that you use a good cooler, a good all-in-one cooler, or a really good air cooler. But the thermal thing is taken into account by the ASUS software when it's doing an overclock. And so if you have an air cooler that is weak, and that air cooler that I'm describing as weak would be 1,000 times stronger than this Intel stock cooler, then you might not be able to achieve 5 gigahertz. And so one thing that the ASUS software will do is say, okay, how much heat can your air cooler dissipate? Maybe we can get 5 gigahertz on 2 cores, which is a really interesting strategy. So these are 4-core, 8-thread devices if you've got the i7. And so what it would do is say, okay, maybe we can get, when you've got a 2-core workload, we'll run 2 cores at 5 gigahertz, but we can't run all 4 cores at 5 gigahertz. Because we can't run all 4 cores at 5 gigahertz because of thermal and heat issues, we'll run all 4 cores at 4.7 or 4.8 gigahertz when you've got a 4-core workload. But when you've got a 2-core workload, we'll run it at 5 gigahertz. And so it's sort of putting the Intel speed step to work for you, because Intel has had that technology built in with Turbo Boost, although it doesn't turbo that high. And so this software from ASUS will basically co-opt that and figure out what that is. And so you may end up in a situation where if you've got good enough cooling, we're talking 5.2 gigahertz or whatever for 2 of your cores, and 5 gigahertz when you're talking about a 4-core workload. So I'm going to strongly recommend that everybody get a really, really nice CPU cooler this time around. It really makes a huge difference, especially when you're doing auto tuning. because for the longevity of your CPU and for reduction in heat production, you really want the voltage to be as low as possible. But, 75–80% of you that pick up, the i7 are going to be able to hit 5 gigahertz, I think, based on the data that I'm getting from ASUS and other vendors. So that's exciting. Let's take a look at the Uefi. This is what you're going to see when you first boot your machine if you've got it put together correctly and your monitor's plugged in and everything is good. New CPU installed. And that makes sense because we installed the i5 in the Strix, so we can take a look at the Uefi. Let's take a look at the i5 7600K. This is the sort of easy mode screen on the Uefi. You can see that we've got a CPU fan connected, and that's pretty much it. And then we've got our boot priority, which is our Linux drive. We can see that we've got our 2 sticks of G.Skill memory. Let's turn on XMP and all that sort of stuff. All right, DDR4 3200, that's detected correctly, 1414/1434, 1.35 volts. Sounds good to me. I'm just going to do that. I'm not even going to... All these other settings were changed just as a result of the easy mode change. Sure, whatever. I'm just going to hit OK. And it's going to reboot. ROG. All right, let's go back into the Uefi. It's good that it booted. All right, now I can see that XMP is on and it's using DDR4 3200. Nice. Okay, let's go into advanced mode because why not? So the i5 7600K is 3.8 gigahertz out of the box. This CPU will hit 4.5 gigahertz on a good overclock at about 1.3-ish volts with a good closed loop all-in-one cooler. It does generate quite a bit of heat at that clock speed, however. Here we can see that from the XMP profile that the memory voltage has been plugged in properly from the XMP profile, which is a nice touch. DRAM timing control. This is where the XMP profile loaded the settings in here. Instead of auto, it's set according to the XMP, 1414/34. Here we can see that we can turn on the thermal monitor, enable or disable cores selectively, can turn on Intel virtualization technology, which I'm going to just go ahead and enable. Platform MISC, PCI Express power management, the DMI power management, and PCI Express power management, and the integrated graphics power management, or I guess, VTD, I'm going to go ahead and enable. Now, if you add in a GPU, it will disable the onboard GPU unless you turn on iGPU multi-monitor. Supports AHCI or RST with Intel Optane support. This motherboard does support Intel Optane technology, so you can use that if you want. Can't wait to get my hands on some Optane parts. M.2_1 configuration mode, SATA mode, PCIe mode, or auto. I'll leave it on auto. As media back USB 3.1 controller, enable, disable, RGB lighting on or off. Oh, and you can turn it off. When we were doing the B-roll earlier, it was off, but the RGB was still on. Gives you UEFI control to turn that off in case it's in a bedroom or something and you don't want the light. Wi-Fi and Bluetooth controller, QFan configuration. We can do QFan tuning. I'm not going to do that. That'll automatically ramp up all your fans and try to find the optimal profile for all of them once you've got them connected to your headers. Here you can set the mode for the water pump control header if it's DC mode or PWM mode, depending on what kind of a fan you've got connected, a 3-pin or a 4-pin fan. Then you can update the UEFI, which we definitely need to do on this motherboard. Graphics card information, there's not any installed right now. Well, that's been a quick tour of the UEFI. Let's take a look at Linux now. All right, we've booted into Fedora 25. Do we have audio? Yep, I can hear the audio in my headphones. Wired network is connected. Wi-Fi is not connected, but that's okay because it can see the wireless networks in the area, so that's good. Here are the PCI peripherals in case anybody's interested. And here are the I/O regions in case anyone is interested. Here's LS-USB, so we can get a tree of our USB devices. Now, I don't have a lot connected right now, but it does appear that everything is working correctly as far as the USB devices go. This motherboard does support Bluetooth as part of the Wi-Fi Go module, and it's nice to see that it works right out of the box in Fedora 25. I kind of expected to have to install some packages or tweak something because that's just the nature of the beast when you're dealing with Bluetooth, but I was pleasantly surprised that it worked fine. Now, I mentioned that the software bundle on the Strix is extensive, and let me tell you, it is super extensive. This is the Strix overview guide actually from ASUS, which confirms that the built-in Wi-Fi is 2 transmit, 2 receive, MU, MIMO, and Bluetooth 4.1, of course. So that's 802.11 ABGN-AC, and you can use both antennas at the same time to double your throughput. It's a nice addition to the board, honestly. Here's a block diagram for the motherboard that shows how all the peripherals are connected together. Alright, so some of the software bundle. Game First 4. This is prioritization software that works with the built-in Intel i219V gigabit Ethernet, and so this is packet prioritization to make sure that your game software that you're running gets prioritization in case there's other stuff going on your network. On your network interface on your computer, like if somebody's trying to copy files from your computer or something like that, that may create a contention for bandwidth on the local wire with your computer, well, Game First will prioritize the game ahead of bulk traffic like that. There's also multi-gate teaming, which will use the wireless and the Wi-Fi connection together to try to bridge the connection, and even a 3G, 4G LTE connection to the internet to try to give you a solid connection for your game, browsing, the whole 9 yards. I have not tested this. I suspect that it might work better with 2 wired connections versus a wired and a wireless connection, but I don't know. I'm not sure. I need to give that a spin. This is the auto tuning and 5-way optimization that I was mentioning before, so we probably don't need to revisit it here. The software bundle also includes RAM cache, which will let you cache your games and things like that into memory. So if you've got 32 or 64 gigabytes of memory or a ludicrous amount of memory, you can copy your entire game to RAM or your entire program to RAM, and then it'll just run from RAM, which is pretty nuts. So Overwolf is software that lets you answer games and dock applications to an in-game overlay, which sounds pretty neat. I did not test it, but it's there. Does anybody use Overwolf? Anybody want to do a guide for Overwolf for the forum? Because if you do, I will totally link it in the description of this video. Another app in the software bundle is Sonic Studio 3. One of the big features of Sonic Studio 3 is to set isolation output and like where the audio from specific applications is routed and per application profile. So you can configure, which thing is going, some things you want over the headset, maybe some things you want over the HDMI, that sort of thing. So this gives you some control over, where the audio is going with a bunch of different audio devices on your computer. You've also got Sonic Radar 3, which shows you where the game or where the application that you're running is requesting that audio be rendered. So you can see sort of a vector here of sound sources around you. So basically in a game where you have surround sound, the game might tell the sound card to make a sound like as if it came from here. Well, the Sonic Radar thing will show you where the game is telling the sound software to actually render an event. So you can use this like a radar, like the name, to see what's happening in a game. It feels a little bit like cheating maybe, but if it gives you the competitive edge and you can get away with it. Now, if you don't want to use the pie chart to see where the source of the audio is coming from, you can also do audio boost, which is it'll override the volume from the directional audio in a game so that you can still hear the direction the sound is coming from, but the sound is much more pronounced to make it easier to hear the direction that the sound is coming from in a game. So you don't necessarily have a visual indicator or a visual overlay to indicate where direction is coming from in a game, but a far away sound in a game doesn't sound so far away so that you can hear it better, so that you can just use your own ears to determine directionality. I didn't mention it before, but the X16 slots are armored, metal reinforced, so it'll tolerate moving around in very heavy graphics cards and shifting and that sort of thing. Well, that's been a quick overview of the Z270G Gaming. This is a micro ATX motherboard, and I really like the micro ATX form factor. If you're thinking about getting one of these or you picked up one of these, let us know your feedback in the forum. That thread is going to be an 18-month long thread. It's going to be really, so if you're watching this sometime other than January, chances are there's a lot of good feedback and good information about this board that has been added to our forum. So there's a link to the forum in the description. Be sure to check it out. Be sure to let us know. And hey, if you want to join, you're more than welcome. If you pick up one of these and you want to do a build, come show it off. Show the people in the forum. I think it'll be great. I'm hoping to do some 3D printing and get some good B-roll of 3D printing for this thing so that you can get some ideas for the kinds of 3D printable stuff that you can do. Because I'm sure that most of you have access to a 3D printer, whether you realize it or not, through university or a local school or, super nerd in your area, whatever. I'm Wendell, signing out. I'll see you later.